Hello YouTubers and welcome back to this phase 3 of where we're trying to make a 4x4 LED cube from the earlier one which I had was 8x8x8 LED cube. So in the last tutorial, as we have seen, that I finally was able to extract this LED cube from that bigger LED cube, and we had talked about how the connections are usually made, the multiplexing techniques used, where we're using decoders and so on and so forth. Now comes the time where we'll actually begin with the tedious work of basically soldering connections to each and every individual pin over here, as you can see. And the connection for connections, I've basically got hold of these 8 female connecting ribbon, where I will utilize 8 for few of these pins and another one for another for the rest of the 8 pins. And for the layer soldering, well, I'll find one single thread wire so that I may be able to solder these as well. So let's begin with it then. So finally we are set and we have connected all the 16 pins to wires, to differently colored wires, where as you can see I have maintained a pattern of black, brown, red, orange, yellow, green, blue, purple, and again repeated. So this will basically help me in connecting these to the decoders later on, so that I may address the black pin always as 00 or maybe 2,0. So I know the configurations and the wires don't mess up, and my programming gets a bit easy. So that's the reason why these codes are basically in a sequence, and that's why I've written it down over here as well, so that I remember while connecting. So this seems to be the front face of our LED cube. Now I need to connect I need to basically connect these layers, the entire layer to through wires to grounds, so that these can be multiplexed as well. So I'll be using this uh, hobby wire that basically comes in the market. It's quite cheap, has a single strand in it, and is good for soldering as well. So I'll cut somewhere around 4 pieces for individual layers and begin soldering. So here we are. Finally, we've soldered all the wires and connected all the individual layers that we had to connect. Now, in order to move ahead, we look into the different aspects of the circuitry that we are going to make. We'll keep this aside for a while now. Okay, so since we've seen that our LED cube has total in all 16 pins at the base. And I'll change this now. So I've seen, so as we have seen basically that our LED cube has 16 pins at base. I'll remind you again, telling you about it. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. 16 total in all. So in order to addressing them, since we will be lighting up only one pin at a time and using a series of sequential events wherein we'll try to light up all the base pins sequentially, like one by one. So we'll be needing a decoder actually. Now we can have our work basically done from a 4 cross 16 decoder, but previously I had purchased a lot of 3 cross 8 decoder ICs. 3 cross 8 decoder ICs. Now these 3 cross 8 decoder ICs, well, they usually come in the market as you can see. It is 74HC238N. The out here the N matters a lot. The 74HC238N matters a lot because this N helps in like see for your remember 74HC238N. This is the number of IC that you need to purchase from your market, from your local market, or order online, so that you can get a 3 cross 8 decoder with positive outputs. Now what do I mean by positive outputs actually? Okay, so there are two types of 3 cross 8 decoders that are present in the market. So one of them is this. Now you have this pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is pin number 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now what is the pin diagram of this IC? So this is your address 0, address 1, address 2. This is my enable pin actually. Enable pin 1 complement, enable pin 2 complement again. This is enable pin 3. This is actually not complement. This is output Y7. This is ground. This is Y6, Y5, Y4, Y3, Y2, Y1, Y0, and this is my VCC. So since it's a CMOS IC, a digital IC, so I'll tell you about the connections that we'll basically do. So this will be connected to the plus 5 voltage via a 7805 voltage IC regulator. These three pins A0, A1, A2, A3, they are actually Arduino inputs. They will be coming from the inputs because these are the pins that this IC will decode actually A0, A1, A2, Y0, Y1, Y2 till Y7. Total in all 8 outputs. And these are 3 inputs. Enable 1 and enable 2 complement out here. They will be connected to ground. Enable 3, this will be connected to our VCC. Y7 is our output, ground is again ground, and these are outputs actually. The arrows show that they are output, and this arrow shows that these are the inputs. So we have a 3x8 decoder IC 238N. Now why I was stressing on this N was, instead of N if you have a DIC, so what happens is these are complemented. For example, if you put an address of 000, then your Y0 pin should be high. According to a decoder, your Y pin should be high and all other zeros. But what happens in a IC which has D, so what if you put a 00 address, what you get, all the pins 1 and this pin specifically as 0. The outputs are complemented, that's what I'm trying to tell you. So in order to get actual outputs, that you need to light up one single output, you need a decoder IC that has N in the ending. So now you must be wondering that I have totally 16 pins and I've been explaining you 3x8 decoder up till now. So I hope you must have understood the connections by now. So I'll tell you how I'll be using my decoder ICs in which configuration, so that I may be able to get the maximum benefit out of these. So as you've seen, let's assume this is a 238N. I'll use 2 of them, 238N. So this is output. Let's assume this is Y0, Y1 till Y7. Similarly again Y0, Y1 till Y7. Now my address pins are A0, A1, A2, A0, A1, A2. So in order to traverse from 0 up till 7 and back to 0, I need to keep these address pins short circuited. Like both the ICs will have their address pins short circuited, and that's the first and foremost necessity that we need. So you see A0, A1, A2, they are the same for both of these ICs. Now there comes a set of pins called as enable pins, which we'll be using to switch between these two ICs simultaneously and selecting our pins. So one of the pin that we know is actually E1 bar. Next pin is E2 bar, and this is E3 bar. So I will be connecting one of these to ground. Okay. Now of this pin and this pin, these pins I will short circuit them and connect them to the Arduino output, and this will be my fourth pin, because we need a 4x16 decoder, right? So this will be my fourth pin. Now if this fourth pin, initially if it is 0, 0, 0, 0, this is my fourth pin, third pin, 2 is first pin. The fourth pin, if it is 0, so what happens is this will be enabled and this will be disabled. If it is 0, this will be enabled and this will be enabled, this will be disabled. So this IC will begin to sequentially output the value corresponding to the address pins. Now, as soon as it jumps to 1, this chip gets disabled and this chip gets enabled, and similarly the consequent pins corresponding to these outputs will begin to light up. And this is how I will operate using 4 Arduino pins and having a 16 total output from 2 3x8 decoder ICs. So my base pins are complete. Now I need layer pins in order to configure them. Now for the layer pins as well, I could have used a 2x4 decoder as well, but I'll try to refrain from using that, because I have totally now used 4 pins from an Arduino, 4 pins of an Arduino. I have a few more pins as well left around which I can use, which can be used. A lot many pins actually. So my base pins, the base has to be connected to the ground for a complete circuit, so that a particular LED may light up. For completing the circuit, these bases need to be grounded depending on which layer you want to light up. So I'll be using an NPN transistor BC547. BC547 usually has a pin configuration of like this. It's a BC547 and its base configuration is usually 3 2 1, where 3 stands for collector, 2 stands for base, and 1 stands for emitter. So I will use a total in all of 4 BC547 transistors in order to switch between my different base layers. So the schematic representation that I can show you out here would be this, where this is a pin whose number is actually like base pin N, and this is my nth transistor BC547, where N is equal to 0 1 2 3, 0 1 2 3 being my 0th layer, first layer, second layer, and third layer. Now these pins are connected to those blue wires that you had seen earlier. These blue wires will be connected over here of individual, like total in all, if I have 4 pins, so these blue wires will be individually connected to these 4 different transistors, and we'll have a limiting resistance at base, collector, emitter, resistance, which I have chosen to be a value of somewhere around 8 kilo ohms, so that there is a current restriction and my LEDs don't blow up while lighting. And this input will be controlled by Arduino GPIO pins. This is the connections that we'll make. So in the next tutorial, I'll basically solder all the components of 74HC238 along with BC547 and show you the schematic, maybe draw it for you later on, that how the connections have been made as compared to the Arduino. Okay, so good luck till then.